Hi there. You can be listening to my voice or merely reading the text on the screen, or maybe both. And that you could have done consciously or completely unconscious, which is more likely. But we can say it was you who made this decision. Oh well, your brains. And this is one of the simple examples, but yet the fascinating things your brain can do. So it should come as no surprise that investigating the brain and how to monitor it has led researchers to do several applications, and also the news of the past year features some of the very interesting applications we can achieve with mobile brain monitoring. Some more realistic than others. But think about it. Can we communicate with our thoughts? Can we control our TV? Or can we even go EEG dating? As you can see, this is a very diverse field. And actually, if you see what people say about this, they say it's amazing. Actually, you can become what you always thought about. Or it's just for nerds. Or it's actually, you don't have to get out of bed anymore. Or it's just junk. Anyway, people worry about the future, or they like the future. At least they're all fascinated about it. And that's what I will talk here on, how to fuse neuroscience and engineering to allow for mobile brain monitoring in a few slides. I'm kidding. So let's first cover the basics of the brain, and that's neurons and synapses. Our brain is one hugely connected network. As we have heard before, networks can be very exciting. And this is one of the biggest in the world, with 86 billion, a rough estimate, of these neurons. And they form really the basics of who you are. And even though people tend to be very different, biologically, the brains, they look much alike. So maybe if we really zoom in more in this tiny, tiny neuron, which is only a few microns in size, how do this work? Well, we can say these neurons are connected to 1,000 to 10,000 of other neurons. And it's these connections that make the importance. And also, two of these cells communicate via a small electrical discharge called the action potential. And you can imagine if many of these cells fire in this process of getting electrical activity, that's something we would want to do, right? To measure your brain, but non-invasively. We don't want to open up your skull. And this problem we can compare actually to a football stadium, where the people in the stadium are the neurons inside your head, and the stadium wall is actually your skull, which is blocking a lot of the signals, because we're standing outside with some microphones, and we're listening to what is happening inside the stadium. And at the moment, you might not really know what's going on, right? How? Now we can actually say that Belgium scored the winning goal on the European Cup next year. So the point I'm trying to make is that if there is enough activity summed over many of these neurons or people, that's something you can pick up from the outside. So we cannot determine a single cell's activity with EEG. So that can be considered one of the downsides. And now I want to take you back to the beginning of where EEG began, the 1930s. Hans Berger in Germany invented and recorded the first human EEG. And a few years later, in 1938, he received a Christmas card from one of the other pioneers, Herbert Jaspers. And they depict some sort of electrical receiving device in which you can send messages with your thought, in this case, wishing you a happy new year. And it's just some vision they had that you could do with your mind. Unfortunately, the signals aren't that clear, nor can we read minds. So what is then EEG, or electroencephalography, all about? So recall again that we have sensors which we put outside the head to record the electrical activity. And many of these we can then, in time, get some signal from. And these are placed more in the front or in the back. And then we can see how signals look. Well, you might not think much is going on. Or actually, wow, that looks like some nice brain activity in the middle. And maybe a detailed eye also spots on the right some spike on few channels. But actually, I have to disappoint the ones who thought that in the middle we have some nice brain activity, because actually these are mere artifacts. This is activity from your muscles, or when you move your head, that's also electrical, and it will contaminate our EEG And it's only these smaller things like these spikes that we're very interested in. So it's a very hard job to separate the real data from the disturbances. And actually at this point you might recognize this EEG because you might even had some EEG measured at some point. And I bet for 99% sure that for all of you this was in a hospital or a research center. And although that's very useful to do a lot of things, it's not very convenient. You have to go back and forth for measurements in a hospital. And this is costly and not the ideal case for neither situation. So we envisioned this might be different. You might go to a center, get your equipment and take it home with you. And then you can record the data at your own time when you think, now I want my recording, and not just that fixed appointment at the doctor's where you suddenly don't feel ill anymore. And also we can record much more data in the same amount of time. So how did engineers actually come up with this? In the past 5 years, they managed to remove huge equipment that was necessary and put it in a very small little box, which is the size of a regular smartphone. So now our channels and the amplifier then just sends the data via Bluetooth to a mobile phone or a laptop. And in this case, we can design new ways of dealing with the brain data. So you can analyze it in real time on your mobile phone and then output it to a screen or on the same mobile phone. And this then can be used to create a loop, which is a simple form of neurofeedback, in which you try to give sense to the level of concentration or fatigueness of the subject, which you then can try to alter or take at the right time a break at work. And yet, besides recording more data, there is another fundamental difference I want to stress between traditional and hospital and research settings versus real-life scenarios. You might imagine that measuring in labs is very restricted, controlled, and artificial. Subjects are put in a shielded room, deprived of any stimuli, and they specifically do some task, which is of course fundamental and useful in a way, but is it how real life really is? I don't think so. We experience many more dynamic interactions and distractions, and that needs to be taken into account.
Well, you can tell everybody. Yeah, you can tell everybody. Go ahead and tell everybody. I'm the man, I'm the man, I'm the man. Yes, I am, yes, I am, yes, I am.
All right. I think you get the idea, right? So the last point here is that with this mobile brain monitoring, you can think about sleep monitoring, but in your own bed, in your own comfortable environment, to really get this personalized sleep. And also, as I mentioned already, neurofeedback, but then in a more complex way. So when having a stroke and you have motor impairments, you can try to relearn these motor activation patterns, and this will be very beneficial to do this on a daily basis at home. And also, as in the beginning, you focus your attention on either source of information. That's something we're currently lacking in hearing aid devices. They don't know which sound source to amplify. And we try to detect that with the EEG and develop this in a connection with the hearing aids. And also brain-computer interfaces. One of the core brain monitoring devices is to give commands to a machine or an assistive device. So think of controlling a wheelchair. And being this mobile, you can actually then go with the wheelchair somewhere. And finally, epilepsy monitoring. So we can detect in the EEG, there are many, many informative parts on when a seizure is about to occur. So if you can detect at home or in people's real lives, just a few seconds before a seizure is about to happen, that the seizure will happen, then these people can prepare for that. And these are but a few of the potential applications that people are working on right now. And now to recap the story I was telling you, is that we talked about the basic principles of your brains, the cells in your body, and how the brain is a huge connected network which works electronically. And that's what we want to measure with EEG. And that there's a huge difference from hospital settings to real-life scenarios with many new and exciting applications. And remember, the brain is the most important organ you have, but that's according to the brain itself. Thank you very much.